Welcome to the AVL Simulation Podcast, where engineering missions take off. Join us as we navigate the evolving universe of digital engineering and simulation in the automotive and energy industries. Explore the forces shaping the AVL simulation software suite and hear how pioneers across the globe use it to outpace competition. Strap in. Our mission begins now. Welcome your host to today's episode.
What happens when engineering ambition meets global energy challenge? I'm Max Sommer, and in today's episode, we explore how simulation is driving progress into hydrogen and industrial energy. My guest is Jürgen Rechberger, Vice President at AVL and part of the strategic leadership of the company's push into sustainable energy systems, from hydrogen propulsion to next-generation electrolyzers. We'll talk about building agile teams, developing digital twins, and why simulation is essential to accelerating clean energy solutions. Buckle up. This one is about scale, speed, and sustainability. We think about AVL as a technology universe. Jürgen Rechberger, where are you located in this universe?
So thanks for the invitation first, to be the first one, right? It's always nice to be. So regarding the AVL universe, my central focus point is in energy, right? So AVL has a little bit of diversification strategy because, as we all know, automotive is a little bit difficult. We are since years working on very strategically on diversification. And one of the main areas we want to go to is energy technologies. And that's my focus area. I have a few other roles still around that. That's still everything regarding hydrogen mobility. Then one focus area is aviation. Another one is rail and another one is marine.
Aviation. Tell us more about that.
Aviation is super exciting because even in my background, when I was 14, I was 5 years in an aviation school. So it's really a lot of fun going back into that. So aviation is one of these hard to abate sectors, right? It's not so easy to decarbonize aviation. And therefore, there are different solutions discussed. One, for example, is just keeping the technologies but switching the fuel to sustainable fuels. That's something we are very active in processes how to generate these fuels. But the second topic, also even exciting, is a hydrogen airplanes running on a full electric propulsion system with fuel cells. And also that we are very active. It's in the public domain that we are working with Airbus on that to develop megawatt scale fuel cell main propulsion systems for passenger planes. So that's really exciting.
Super. So now we know where you're located, but what do you actually do all day at AVL?
So in theory, what I should do, so we have about 2 years ago created a dedicated global business segment with all these topics I have said before. It's called Hydrogen and Industrial Energy. And I'm basically running this global business segment, so pushing forward our business. I would say I'm the main stakeholder for all these different areas to keep everything together, follow our strategy, develop our strategy, and grow this business for AVL.
Cool. If you had to give your role a nickname, what would it be?
I would say that would be Mr. Sustainability, right? Because I have coming from my background, a very, very strong focus on sustainability. And my business is, I would say, to 100% ESG, SDG business. But that's really, I'm convinced that we need to work on sustainability, and that's really my driving force.
Great. Talking about your background a little bit more, what got you into engineering in the first place?
Actually, in the first place, I did in any case something else. But it's a longer history. But I started actually, as I said, 5 years in a school for aviation. Then I went to Vienna in the University for Engineering. But in parallel, actually, I was very much into the music industry. Mm-hmm. So I was studying in Vienna to be a DJ. I was actually more in clubs than in the university. And then I stopped the university even for 1.5 years, went to New York as a professional DJ.
Okay.
That was fun. But I figured out that it's probably not the healthiest way of life. So okay. I had to stop that. there were too much influences around. So I went back to university, finished the study, and then I got an offer from McKinsey. So I was working then 2 years for McKinsey, went to Los Angeles. And there actually Los Angeles was a very interesting period at this time because all this emission came up, zero emission vehicles. CO2 was not a big topic, that's 20 years ago, right? Mm-hmm. But at least the zero emission was a very big topic. And then I started really to get interested and excited about that. But at McKinsey, I learned from me that I cannot have the impact I wanted to have, right? It's more consulting, it's boundary conditions, it's business cases. So I thought I will have a bigger impact on sustainability in an engineering technology company. And that's how I came to AVL.
Awesome. So technology and engineering with bigger impact in your point of view. When people gather around you, what do you think is your gravity? What do people come to you for?
Probably that's a few points, but for one, sure is my drive and my spirit for sustainability, for innovation. But still, I'm not a research guy, right? The research guys are usually, we shouldn't say that, but a little bit of nerds, right? I think I'm not that. I'm considering innovation, but how we can make a business out of it, right? Mm-hmm. Because we can only bring these new fancy technologies into the market to help us on sustainability when they are to some extent a business case. And I think I'm pretty good in bringing all these most important topics together, right? Innovation, sustainability, but then making also a business case out of it.
You have mentioned the term sustainability already several times. What is the deeper meaning for yourself when you say sustainability?
For me, sustainability has different elements and different levels, right? One is pretty obvious, that's this, we need to do something against climate change, right? I see this as the biggest threat mankind is facing, so we need to do something against it. But for sustainability, for me, is much more than that. For example, even in relationships, right? Mm-hmm. You should tend privately to have sustainable relationships. We need on the business side sustainable relationships. So I see it really as a broad thing. Not only related the environment.
Going back to your everyday work life, give us a tool that makes your day 10 times more productive.
That's an easy answer. Easy answer here. That's coffee in the morning. That's the most important thing. Otherwise, nothing would work. And that's really I need to have that. Otherwise, I cannot even go into the first meeting.
So besides coffee, is there something that you would tell our audience you might suggest somebody else in your industry as well to do as a habit, as a daily routine maybe?
One thing for me which I really need to have is really staying up to date, right? I have a brain which needs to be occupied 24/7. So my brain basically never rests. So I will always need to confront it with what's going on, right? So I read, I spend time on social media. I read a lot of stuff all the time, and it's not only into my area, right? I want to understand what's going on in politics and economics, and that's really important for me.
So when you say your brain never really turns off, you might also have a trick or a habit that makes your brain rest and get at ease at some points.
Yeah, for sure. That's still. I was a DJ, right? So music is still super important for me. I'm learning languages for relaxation. It just might sound a little bit strange, but I'm learning now since 2 years Japanese, and it's a lot of fun. I really like it, but music is more for the relaxing phase. And in my job, I'm traveling about 60% of the year, right? I have a lot of travel time, and I usually fill that up with music.
Sweet. Now, hard change, big curve in our discussion. Let's move into simulation, virtualization, and digitalization. What role does simulation play in your area?
Super important one, right? So I can today not even imagine to develop a product without simulation. So it's core of what we do. And for me, really, it is mostly, I would say, if I should choose one of the main drivers, I see development speed, right? So that's for me the key, that we can push the technology, we can push designs, prototypes in the virtual world first, because before we even touch hardware. So that's really the key, I think. But it's such a natural thing to do. I cannot even imagine to develop a product without it.
Mm-hmm. When thinking about the energy sector, one of the most important topics are electrolyzers. What opportunities and horizons do you see for simulation in the development of electrolyzers?
Yeah, quite a lot of actually. So electrolyzers today, I would say, are still at a let's say average maturity level, right? There's still a lot of things to be improved, because so far this market was very small. There was not put too much effort in the development of really high quality mature products, and we are now addressing that in our usual way of working, applying a lot of simulation in that. I think where we are pretty good with electrolyzers is already on the whole performance simulation.
Mm-hmm.
I think that's more or less solved. But I think there's a lot of potential to extend these capabilities more into prediction, right? So we need here prediction towards remaining lifetime, to optimize the whole thing, to optimize towards levelized cost of hydrogen. So I see a lot of potential here.
Now, in the automotive industry, virtualization is one of the biggest drivers for change. Give us some insight of the energy sector. How is it there?
I would say it's not the energy sector is a little bit is actually very different to automotive, right? The products are different, the way to develop is different. For example, on the product side, we are talking about products which are 10 to 15 years in the field. So you need guaranteed lifetime of 100,000 hours or even more. So if you look into a power plant, that's basically designed for a lifetime of 30 years, which means also that the products are much, much longer in production. So that's on the one hand side. On the production side, on the product cycle is completely different.
Mm-hmm.
But on the other hand side, also the way to develop products is very different, right? Because in the automotive, we all know in Europe, we have this A, B, C, D sample till start of production. That doesn't exist in the energy technologies. So there is, in principle, they have, in the energy world, we have a one generation development approach. So as the first thing, what you develop, is it an electrolyzer or whatever, goes already into the field in a field test, ideally with a friendly customer.
Mm-hmm.
You learn from that and feed that back into the design. But that's it, right? Then the thing goes into production. So it's very different to automotive.
So coming back to the role of simulation, maybe we take a little deep dive here, looking at the electrolyzers. What capabilities do you see, especially at the electrolyzer development?
I mean, one big thing we are working at the moment really is, we have to separate, of course, different electrolyzer technologies, right? One topic we have put as a real focus topic this year is damage simulation and remaining lifetime prediction.
Okay.
So what we're doing here, we do that at the moment for PEM electrolyzers, which are now getting a lot of attention in the market. It's pushed into the market by pretty big players like Siemens Energy, Nel Plug Power, so really big players behind it. But what we see is we're still lacking on durability on the one hand side, but also on capability to predict the lifetime.
Mm-hmm.
And therefore we are now working here on a strategic approach to really break that whole thing down into physics-based damage models,
Mm-hmm.
which allow us then really to have a virtual twin, which is basically simulating what's happening in real time. But we can then predict always based on certain operating parameters, the actual degradation status, and then do optimizations to extend the life, right? Because that's the objective. At the moment, we are not meeting the industry targets. So we need 60 to 80,000 of lifetime, and we are probably at 40.
Okay. Many people in our audience consider AVL as one of the leading players in the automotive and mobility industry. So everything you're talking about right here is outside of this industry. So why AVL? Where is AVL's value and capabilities in this new energy sector? For AVL new energy sector?
Yeah. I mean, for electrolyzers, I think the synergy where we are coming from is the automotive fuel cell, right?
Mm-hmm.
We have developed, 10, 15 fuel cells for automotive. An electrolyzer is a very similar process. And I think we have a lot of background know-how from the fuel cell, which we are now transferring to the electrolyzer. And I think it works quite well. because we also bring in a little bit more systematic development approaches. And in particular, what's not so used in the energy world is a lot of these simulation capabilities, right?
Okay.
So I think that's a real USP, that we come with the whole automotive background from our development methodologies and bring them also with the domain know-how of the electrolyzer into the energy world. Of course, we also have to change, right? We cannot now in the energy world do our ABC development, which takes 5 years, right? Also, we need to change in the development approach. But I think we learned that, we set it up. We have now standard development approaches for energy technologies. And that's I think now we are real at a little bit of a sweet spot to bringing the whole years of decades of expertise from the automotive in the energy world.
Great. One more sudden change in this discussion and in this talk will lead us more to the team and the people behind this change that you mentioned. What are you looking for when establishing and developing a team to drive change, as you mentioned?
I think also here it's various elements, right? You need a certain technology know-how. You need the skill to develop such a product, right? And this is also different to the past, because for these electrolyzers we need completely different skills. It's not only mechanical engineering or something like that, right? We bring in completely new skills like electrochemistry, chemistry in general. Of course, we again have mechanical engineering for sure, but there's a lot of electrical engineering. So it needs much more domain and skill knowledge from different areas. And from the personalities, of course, I believe I really like to work with agile people, which are not so much process driven. And I think that's in general something in Europe we need to reconsider if we look into development times, even on the automotive, when we are twice as long or even more than our Chinese friends are developing these products, right? So I think in general, in everything we do, we need to look how we become more agile and do not block ourselves so much by methods and processes.
Let's try to take a deep dive here as well. Give us some examples in the energy and the development of electrolyzers, maybe, where you could see agility and having an agile approach.
I think I have a pretty good example for that. So we started, for example, PEM electrolyzer stack development, which is completely new for AVL. We started that last year. We have a dedicated team for PEM fuel cell stack design in Vancouver in Canada, right? Which we built up about 6 years ago. And we gave them the task last year, guys, now fuel cell is nice, but now we need an electrolyzer, right? And of course there were a little bit of hesitation, some resistance, but we convinced the team. And they then put together a very, very agile, very dynamic approach. And so we started it in January, and in September we had the first PEM electrolyzer stack on the testbed with actually superior performance to the market. So we achieved 73% efficiency, which in the industry average is around 60 to 63 or something like that. So even that, a perfect result. And then based on this result, we could even already convince a month later one of the biggest energy technology companies of China to develop for start of production a 2.5 megawatt electrolyzer stack, right? And that was only possible by a very agile team accepting the target and go for it.
Cool. Before we come to the finish line, I want to go back to the virtual twin one more time. You have mentioned it. It is one of the most used buzzwords in probably every technology industry, for sure in the automotive and in the industry sector and energy sector. What's behind a well-working virtual twin?
I think I can tell you where we want to go to, because we are not there yet, right? So virtual twins of the industry is to some extent already using that for pretty simple tasks, for predictive maintenance and things like that. But where we want to get to is really to extend what I mentioned before, to extend that to really more reliable information on remaining lifetime, on durability, on recommendations, for example, to change the operating conditions to extend lifetime. And one additional aspect is, of course, electrolyzers are very much driven with renewable energies like solar and wind. So we might even include some weather information, real time, some outlook for the next 7 days, to really optimize the strategy, how you operate it, optimized in terms of lowest possible degradation, and at the end, considering all the weather environment also towards lowest cost of hydrogen, which is the target at the end of the day.
Great. You mentioned something that we are working towards too. What do you think is the timeline?
One big step, I think we are addressing this year with the damage models, right? Because that's one of the key. I think when we have that, probably we need another year to implement the other functionality. So I think in about 2 years we could be there.
Great. Last question here. If you had to give your 20-year-old self some advice for his future, what would it be?
I think it would be what to some extent I did also is stay with that what you really believe in, right? Do what you believe in. Don't get distracted. In this world we live today, there's a lot of distractions, right? And a lot of that is not necessarily helpful. So really find the things you believe in and then follow this mission.
Jürgen, thank you so much for your time.
You're welcome. It was nice to be here.
Thanks for joining us on the AVL Simulation Podcast, where engineering missions take off. We hope today's journey through the world of simulation sparked new ideas and perspectives. To keep up with future episodes, subscribe wherever you get your podcasts. And if you're ready to accelerate your digital engineering mission, visit avl.com for more insights. Until next time, keep simulating, keep innovating, and keep pushing the boundaries.